Assalamualaikum to one and all. Welcome back to Sir K Loves Physics and Chemistry tutorials for high school students. In today's episode, we go back to the basic. How do we compute the magnitude and direction of a resultant force? Join me as we compare two methods, applying the sine and cosine laws and the component method. So stick around, watch and learn. The question is, given the two concurrent and coplanar forces acting on a particle shown in the diagram, we have force F1 with a magnitude of 50 newtons and it forms an angle theta equal to 30 degrees above the positive x-axis. And the other force F2 has a magnitude of 30 newtons and it forms the angle phi equal to 160 degrees counterclockwise from the positive x-axis. Alright, so the question is, find their resultant force, both in magnitude and in direction, using the sine and cosine laws. And verify your answer by doing the component method. As shown in the vector diagram, we connect the three vectors or vector arrows, right? The red arrow representing F1 and the blue arrow representing F2. So each force has its magnitude and the angle it forms with the positive x-axis, right? The three vector arrows are connected head to tail, right? So the force F2 is connected from the head of the force F1. And we have a rule that when the two given vectors are connected head to tail, the resultant is drawn from the tail of the first to the head of the second vector. And that is represented here by vector R, which is the resultant force, the one in violet, right? And you will notice that the three arrows form a triangle that is not a right triangle, right? Because the angle opposite to F1 is greater than 90 degrees, all right? In order to determine the magnitude of the resultant force big R, we first have to know what the angle alpha is, all right? The angle alpha is the angle opposite to the big R or the resultant force R, right? And that angle alpha happens to be equal to the angle theta plus 20 degrees, all right? Angle theta being 30 degrees. That's the angle that F1 forms with the positive x-axis. And then, when added to 20 degrees is the difference between 180 degrees, all right, and 160 degrees. 160 degrees actually is the angle phi that F2 forms, okay, relative to positive x-axis. All right, so that's how we got 20 degrees. 180 minus 160. In short, the angle alpha is equal to 50 degrees. Now, in determining the resultant magnitude of the resultant vector r, all right, uh, we imagine that the force F1 represents the longest side of the triangle, all right, which according to cosine law, right, that is denoted by side C of the right triangle, while the resultant force big R corresponds to the side we label here as side B. And of course, side A is represented or corresponds to the force F2. So this is the cosine law, all right? To determine the side B of this right triangle, we just get the square root of c squared plus a squared minus 2 times a times c, and the cosine of the angle opposite to side B. We label it as angle B. So that's the cosine law. When translated in terms of our given quantities, all right, the resultant force big R corresponds to the side B. So that is equal to the square root of F1 squared plus F2 squared minus twice the product of F1 and F2 and multiplied by the cosine of the angle alpha. Plugging in the quantities into the cosine law equation, we get the magnitude of big R equals square root of 50 newtons squared plus 30 newtons squared minus 2 times 50 newtons times 30 newtons, and that will be multiplied by cosine of 50 degrees. So when we do our math, we get the value of the resultant force big R equals 38 newtons. How do we determine the direction of this resultant force? All right. So in our diagram, we denote the angle formed by the resultant force big R and the force F1 as angle beta. And angle beta can be determined using what we call the sine law. All right. The sine law states that based on our uh, triangle diagram, side B, right, divided by sine of the angle alpha is just equal to side A divided by sine of the angle beta. Or, since side B represents the big R, right, so big R divided by sine of angle alpha equals 50 degrees is just equal to side A or F2 divided by sine of the angle beta. Isolating sine beta from our equation, the equation known as the sine law, right? So sine beta is equal to F2 multiplied by the sine value of 50 degrees divided by the value of big R, right? Substituting, that's sine beta equals 30 newtons multiplied by 0.766. That's the value of sine 50 degrees in 3 significant figures divided by 38 newtons, right? And since what we are looking for is the value of the angle beta, we can determine that by getting the inverse of the sine value of 0.605, which is the result of multiplying 30 newtons by 0.766 and then dividing by 38 newtons. All right? So, with the help of your scientific calculator, we find the angle beta equals 37 degrees. Therefore, our final answer, okay, we have a resultant force, big R, with a magnitude of 38 newtons, and whose direction is 67 degrees above the positive x-axis, right? Because, going back to our diagram, um, it is more appropriate to use an angle, okay, formed by the resultant force big R with respect to the positive x-axis, right? And that would mean that the angle that we have to use is the sum of angle beta and angle theta, where angle theta, of course, is 30 degrees. So 30 degrees plus the angle beta, which is 37, that gives us 67 degrees. So this is our final answer for the question, what is the magnitude and direction of the resultant force of the two given forces, F1 and F2. To verify our answer, we use another method known as the component method of determining the resultant of two given concurrent and coplanar forces. All right, starting with finding the x component of the force F1. Right, so F1x, that's the x component of F1, is just getting the value of 50 newtons multiplied by cosine of the angle 30 degrees. All right, why cosine? It is because if you look at our vector diagram, F1 represented here by the vector arrow colored red, all right, it's what do you call, the angle that it forms with the positive x-axis is denoted by theta, which happens to be 30 degrees, all right? So the adjacent side, all right, the adjacent side of the triangle that can be formed, the right triangle that you can form, all right, a right triangle with F1 as the hypotenuse, and the x component of F1 is described as the adjacent side of the right triangle. All right. And by definition, if you recall your trigonometry, the meaning of cosine is adjacent side divided by the hypotenuse. All right. So the adjacent side is what we want, okay, represented by F1x. So if you divide F1x by F1, adjacent divided by hypotenuse, then that is the same as the cosine of the angle theta. Hence, we came up with this equation for finding the x component of F1. All right? So, multiplying the value of 50 newtons by the cosine of 30 degrees, we get the x component of F1 equals positive 43 newtons. All right? The positive sign suggests that the x component of F1 is directed into the positive x-axis or to the right. Now, how about the y component? We label it as F1 sub y, right? So for the y component, we just multiply 50 newtons, that's the value of F1, by the sine value of the angle 30 degrees. Because by definition, when you say sine of the angle theta, we are actually referring to uh, the opposite side, right? The opposite side of the right triangle divided by the hypotenuse, right? Now, not shown in the drawing, but the opposite side is in fact the y component f1y directed upward, right? So, since that is what we want, all right, the y component of f1, so we simply multiply 50 newtons by sine of 30 degrees, which is, of course, we know that sine 30 degrees is equal to 0.5. Multiplying that by 50 newtons, we get positive 25 newtons. Again, the plus sign means that the direction of the y component of F1 is into the positive y-axis or directed upward. Similarly, for the force F2, all right, its x component labeled here as F2x can also be determined by multiplying F2, which is 30 newtons, and again, the cosine value of the angle phi, which is 160 degrees. All right. The angle phi, all right, is measured from the positive x-axis in the counterclockwise direction. So, as indicated by this uh, semicircular curve or arrow. All right. So, with the help of your scientific calculator, we'll find that the product of 30 newtons and the cosine of 160 degrees is in fact equal to negative 28 newtons. The negative sign, again, suggesting that the x component, f2x, is directed into the negative x-axis or to the left, right? And lastly, for the y component, f sub 2y, we just use the sine of the angle 160 degrees and then multiply it by 30 newtons, we will get positive 10 newtons. Our next step is to add the two x components, right? We label it as summation of fx. And that is equal to uh, positive 43 newtons plus negative 28 newtons. So that will give us the summation of f sub x equals positive 15 newtons. And in the diagram, all right, our vector diagram, this summation of fx is represented by this red arrow, all right, pointing towards the positive x-axis, all right, because it is positive. While the summation of fy is just the sum of 25 newtons plus positive 10 newtons, of course, that gives us positive 35 newtons. And in the diagram, that's represented by this green arrow directed upward or into the positive y-axis, right? Now, we can find the magnitude of the resultant big R by using Pythagorean formula, right? So the Pythagorean formula in finding the magnitude of the resultant force big R is just equal to the square root of the sum of the squares of summation of fx and summation of fy, right? So substituting the values of summation of fx and summation of fy and getting their square values, Then adding them and finally getting the square root, we will get 38 newtons as the magnitude of the resultant force, big R. Right? And to determine the direction of this resultant force, all right, we again define an angle. In the diagram, the angle formed by the resultant force vector with the positive x-axis, and we label it here as angle gamma, right? So, in determining the value of this angle gamma, we make use of the meaning of the tangent of the angle gamma, right? Since if we are going to um, draw the projection of summation of fy and transfer it on this side, connecting the head of the red arrow and the head of the brown arrow, right? We call that the projection of summation of fy. We'll come up with a right triangle, right? So the right triangle is the reason why we were able to apply the Pythagorean formula in determining the magnitude of the resultant force, big R, right? And we can also use the definition of tangent of the angle gamma. That is, the value of the angle gamma can be determined by just getting the inverse tangent of the ratio 35 over 15. 35 refers to the summation of Fy, which is the opposite side of angle gamma. And 15 newtons is the, or represents the summation of Fx, which happens to be the adjacent side of the angle gamma, all right? So opposite divided by adjacent, that's the reason why we use gamma or tangent, all right, as the function. And with the help of your calculator, scientific calculator, we will be able to get the direction of or the value of the angle gamma, which is exactly 67 degrees. Hence, our final answer is that the resultant force, big R, has a magnitude of 38 newtons and directed 67 degrees above the positive x-axis. And this answer jives with our first answer earlier when we use the sine and the cosine laws. So you see, it doesn't matter which of the two methods you will use in computing the resultant of two concurrent and coplanar forces, right? So that concludes today's tutorial. Till the next session, mabuhay, mashallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.